Hello, so in this video I'm going to demonstrate a few examples from 9.2 on estimating a population mean. Now, when we look at estimating a population mean, usually you have that there's two things. You have that x bar is normally distributed, and you also have that sigma, the standard deviation for the population, is known. Okay, so if we wanted to find, say for example, a confidence interval with this parameter, essentially we would need to use the following. So whenever we have a confidence interval, we have that it's given by the formula x bar plus or minus t sub alpha divided by 2. We can actually write that again. Okay, so let's write it like this. We have t sub alpha divided by 2 multiplied by the standard deviation, and this is all divided by the square root of n. Now we can kind of tell that the uh, margin of error is given by the product. So just keep that in mind that when you're looking for the margin of error, you're just looking for that piece. So we can actually use this where we'll say that the margin of error is given by E equals to, so we're going to say that this is T sub alpha divided by 2 times the standard deviation divided by the square root of n. But if you're trying to estimate the sample size, the problem with estimating the sample size is that in actuality, and we'll do this, in actuality the sample size is given by n equals 2. Okay, so this is where it gets a little complicated. We have that'll be z alpha over 2, and this is multiplied by the standard deviation, all divided by the margin of error, and we just square that. Now, in this case, we also tend to use, whenever we're dealing with a t-distribution, we have to also include that there's what we call a degrees of freedom. The degrees of freedom is given by n minus 1, but this is only applied whenever we're using like what we call the t-distribution. So for these two, we have that this applies to the t-distribution. It gets like little nicknames like the student distribution, but I mean you can just call it the t-distribution. The other thing of which that, and we can probably just fit it right here, is that whenever you're looking at the normal curve, well in this case the t-distribution, your textbook and also your calculator, it looks at the t-distribution and it says that, for example, that t sub alpha divided by 2, it's actually giving you the area that's to the right as opposed to the left when you're looking at the normal distribution. So that's just one thing that you'll have to consider, like whenever you're messing with the the t-distribution, sorry. Yeah, so that's just like one thing to look at. The other thing that you would need to look at, for example, is like how do you get the standardized version of the t distribution? Um, so let me just double check that I've kind of mentioned everything else. So right, so the standardized form of the t distribution is given by, so it's given by taking that the t value is equal to x bar minus the mean, all divided by the standard deviation, which is the square root, divided by the square root of n. Let's just make sure that that's correct in terms of the notation. Um, okay, so yeah, I guess we can change the standard deviation to s, but I mean, to be honest, it's more or less the same thing. Um, yeah, so if you want, you can change this to an s, but I mean, as long as you know that you're dealing with a standard deviation, then you can always just replace it with the given information. But we'll go ahead and just be a little consistent with the formula. So we have s, and then the standard deviation for the for the sample size will still be the same though, because we're trying to avoid having to kind of like to guess and check the sample size until you get within error, the desired error, or even sample size for that matter. So I'll just put an S right there. And yeah, if I'm correct, I think the standard deviation should still be the same. Just closing a few windows here. Okay, so let's see. Yeah, oh, okay, so it's actually just S. So you're just changing the perimeter, or the parameter Z. Okay, so yeah, this is correct, and then okay, so that's going to be S. And yeah, we have to change that too. Okay, so we'll just put an S right there. But for most part, like we can see that our examples will be more or less a little bit straightforward in like what do we have to do. So like for example, we have that we want to construct a 95% confidence interval for the population mean, and we assume that the population has a normal distribution. We know that the sample size for this question, so a sample of 20 part-time workers, had a mean earnings of 3,120 with a standard deviation of $677, and it says to round to the nearest dollar. So here's what we know. We know that basically we have that we're looking for x bar plus or minus this critical point of t alpha divided by 2 multiplied by the standard deviation, all divided by the square root of n. Now the things that we do know is that the mean, that we can just say like x bar, equals to 20, no, not 20, 3,120. So yeah, that should be $3,120. And we know that the standard deviation is going to be 677, and that n is equal to 20, which means that the degrees of freedom actually equal to 19. Now, the question that we need to address is how do you find T alpha over 2? Well, we know that, for example, that you have 1 minus the 0.95 confidence level, which is going to be 0.05, but you need to divide that by 2, seeing as all confidence intervals for a t-distribution is two-tailed. So we'll just say that alpha over 2 is equal to 0.05 divided by 2, which is equal to 0.025. So what that means is that we need to look for t equals to not point 0, but well, what we're trying to say is that we're looking for when t sub alpha, yeah, we're looking for t alpha over 2, which is 0.025. So let's do this a little more accurately. So where we have t sub 0.025. Okay, so in any case, we're looking for when the area is 0.0975. But we can do this by using our calculator. So let's say that we go ahead and we use the calculator where we open up our TI-83. Okay, so let's go to second vars, and we're going to use inverse t. Now the area that we're going to use essentially is, let me see, so we want to account for up to the 1, oh yeah, so we can just do this, 1 minus 0.025, and then the degree of freedom is 19. So let's just go ahead and hit enter, and it gives me 2.09, which let me just refer to here that this is correct. So 2.093, yeah, so this is correct. So that means that we have that the critical value is 2.0930, and I believe that's all that we need because we have pretty much everything else that we needed to get. So for example, we have that this is going to be 3,120 plus or minus 20930, and all of this is multiplied by the standard deviation of 677, all divided by the square root of 20. So what we need to do is to find the margin of error. So the margin of error is basically going to say that you're going to take this, multiply it by 677, and then divide by the square root of 20. Right, so we hit enter, and we figure out that that's 316 and 85 cents. So this is going to be 3,120 plus or minus, so we have plus or minus 314 and 85 cents. I think it's 314, 316. Okay, so 316, we'll just change that a little bit. It's just by $2. Okay, so that's gonna be 316. Now we need to find the lower bound, so essentially we'll just take the 3,120 minus 316.85, and that gives us 2,803.15, and we might as well do like the other portion of it, you know, like where we add. So we're just going to add 316.85. Now, mind you that the question did say to round to the nearest dollar, which basically means that we have our upper, we have our lower, and the way that we're going to notate that is 2,803.15, and then comma, let's see, what is that comma going to be? 334.36 and 85 cents. So 334. Hang on, that doesn't sound right. 34.36. Okay, so it's 34.36. And okay, so 34 36.85. Okay, so what that means is that basically the answer, since it said to the nearest dollar, that means that the average earnings is between 2,803 and 3,437. We could probably just write this again so that way it looks a little cleaner. Okay, so $3,437. So that answers, like, just finding the confidence interval for that question. Okay, so, and we can double check our work from our lecture notes. So yeah, that looks about right. Yeah, yeah, we're just off by a little bit because it's somewhat like some rounding errors. Okay, so the next one that we're gonna look at. Okay, so this one was just finding the confidence interval. Okay. Now there is another way that you can do the confidence interval, which in this case would be stat calc test, and you just select the t interval. Now, because of the fact that you wanted to use a specific confidence level, then we can do that. Now, basically the question kind of said something like the mean was 3,120, so technically we can just do 3,120. And then the standard deviation was 677, and the sample was 20, sorry, and the confidence level was 0.95. Now, if we don't get the right answer, then it just means that we need to divide the standard deviation by square root of 20. But since it says s sub x, that's the estimated. And this looks correct. So we can see that this is going to be 2,803 and then 3,437 if it's to the nearest dollar. So if you're catching me using the t interval, like the function on the calculator, then it's either or, to be honest. And this isn't the only way to find the confidence interval. Okay, so let's say that, for example, that we look at one more question. So we have the resting heart rates of 25 statistic students. Okay, so these are their beats per minute. Now, what I want to do with this sample, and this should be like 25, sample of 25. So we have that this is 25. I need to find basically the sample mean, but I also need to find the standard deviation. But for that matter, I also need to find t sub. Okay, so you have a 90% confidence level, so this is actually t.05. Okay, so what that means is that yeah, so what this means is that we just need to find the t alpha divided by 2. Okay, so there are several ways that I can basically find this. So let's go ahead and find the t alpha over 2. So 2t equals t.05. Now if we do this, like if we do second vars, and then we just go to inverse norm. Now really all that you need is the 1 minus the 0.02. I believe it's 0.02. Yeah, because you have the percentage is 10%, which is the alpha, but since it's two-tailed, it's divided by 2. So what that means is that we're just going to say minus point, hang on, that should be 0.5, yeah, 0.05. The next step is that we know how many samples there are. There's 24. So this tells me that my t-value is 1.7109. Okay, so this is equal to 1.7109. Now, what this means is that we have everything that we need, except that if I go ahead and I try to find the mean of these, this data set, I'm actually going to find that the mean of this data set is equal to, let's see, the mean was, let me see. So the mean apparently, if I do the calculator method, is 77.4. Okay, now I'm actually going to show you how we can get that information. So for example, I'm going to use Excel, and I'm going to say equals to average, and then I'm going to tell it actually, yeah, I'm going to tell it from where to where, so A2 to A. So I already pre-entered this information into the calculator. So, not calculator, but Excel. Okay, so it appears that the mean is 77.4. Okay, so I have 77.4, so that's the mean. So that takes care of, yeah, this mean. Okay, so we have this mean is 77.4. And then from here, we're going to look for the standard deviation. Now, technically, I can look for the standard deviation and then take S and just divide that by the square root of n. So this would actually be divided by the square root of 25, and we just need to get the standard error. But to get the standard error, let's do it like this. Okay, so we're going to do equals standard deviation. Okay, deviation. Okay, so we're going to do the same thing. We're going to do A through A26. Now if I hit enter, this is only going to give me the standard deviation. Okay. So apparently it's 9.7639. So we can either use that or just the standard error. So we have, let's see, go back. We'll go back. Okay, so 9.7639, 9.7639, 9.7639. Now if you want to input more parentheses, you can. Okay, so let's go back over here, and we're actually going to go ahead and add more to this because I actually want everything to be I actually want it to be what do you call that, all in one. So we have square root of count. Okay, so this is a little strange. We're going to count A2 through A26. We're going to close that, so it should count 25. And if you want to see this, you can. Oh, no, wait, we'll show it in a second. So then we'll just close this and then hit enter. And I get a standard error of, yeah, I get a standard error of 1.9527758, which is approximately what was calculated using StatCrunch. Okay, now if we go ahead and we go back, so we have the standard error. It's 1.95. Okay, so we have 1.95, and then I think it was like 277, or yeah, 27758. 27758. Okay, so in this case, like we go ahead and we find the lower limit. So, wait. Okay, so um, okay, so um, okay, so we have that the mean is 77.4, and I'm just going to put minus, that way we just do all this in one, so 1.7109 multiplied by the standard error, which is 1.97, no, 157758. Let me see that that's correct. 9527758. Okay. Now this represents the lower. So we have that this is the lower. And then if we do this computation using our calculator, so we have 77.4 minus 1.7109 multiplied by the standard error. And I did it as standard error so that we didn't have to do it again. That should actually be 27, I think. Yeah, there's a 2 right there. Let me just squeeze it in. So it's 27758. And yeah, this is very close to what the answer is. So it gives me 74.0590. Okay, but that's really just the 74.1. That's the average heart rate. And then now we can just find the lower. Not the lower, the upper. So we have that we're just going to use the lower. Okay, so the lower is going to be, not lower, I keep saying lower. The upper, that's going to be 77.4 plus or minus. Now, keep in mind that you could have probably just found the margin of error instead, and you would still get the same thing. The whole point is that you kind of find the way that you prefer that works for you. Okay, so what this equals to, and in actuality, we don't really need this minus because we're already calculating the upper for this matter, so it doesn't. We don't need this. Okay, so what I'm gonna do in my calculator, I know you can't see it. I'm gonna basically just insert a plus symbol and then delete the minus symbol because I'm trying to do the least amount of work. And I get I get 80. So I get 80.7410. So there's my upper. And keep in mind that I did this uh, without actually showing you, like, for example, how you get the standard deviation and the mean, because I wanted to do it in a way that that we didn't really need to see the part like how do you estimate the mean, how do you estimate the standard deviation. Because one thing that I'm going to do with this one is that before I go back to my Excel, I'm going to show you, like, okay, how could I have used the calculator to help me find the confidence interval. So this is kind of interesting. You go to stat, you go to calculator, go down to the t-interval, and then we're going to use statistics. So believe the mean, what was the mean? Okay, so sorry. The mean is 77.4. Okay, so we have 77.4. And the standard deviation was that big number of, I think it was 9.7. Go back over here. So 9.7639. Okay, so 9.7639. It's very likely that we might be off in our computation, but it's okay. There were 25 samples of rates of heart, and I think we were using a 90% confidence interval. Let's see. Yeah, 90% confidence. So this is kind of interesting because if you just go to calculate, it's supposed to give you exactly. So check this out. So we have 74.059 and 80.741, which is pretty much the same exact thing. The same exact thing that I got over here. So if we use Excel, essentially, okay, yeah, we did use the calculator to find our confidence interval, and I did kind of borrow a little from Excel already. But check this out. If we use Excel, then in this case, if we use Excel, so let me go back to Excel. I found the sample mean, I found the standard error. I wrote down my degrees of freedom, but in order to find the lower limit, we're still going to have to use the inverse norm, inverse t, to find the, like the value, the critical value t. So in any case, it's 1.7109. So the way that I would do this is the following, because the standard error doesn't really account for the margin of error. So if you want, we can add in another column where we just put t, I'll call it t value. Okay, that's mostly because, like, it doesn't really matter like what we call it technically. I mean, we just need to know it's the t. Once we look into the value, so 1.7109. Once we look into the part about test statistic, or like hypothesis tests using t distribution, you're gonna see that essentially it's not too bad. And yeah, it doesn't really matter what we call it, but that's normally what we use the t-value, or the critical. It's really called the critical test statistic. Or no, 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 not. Okay, so yeah, you have critical points, and then you have test statistics. So this would be the critical t-value. Okay, so I want to calculate the lower in the following manner. This is kind of interesting because you can take d4 minus, okay, so we're going to take f4, and we're going to multiply that by the standard error, so that's going to be e4, and then we're just going to hit enter. So what do you know? It gave us 74.06, and I want to find the same thing, but we'll just use the same formula, and then we'll just change it to a plus symbol. That doesn't seem right. Oh, okay. It got confused in the approximation. So this E should be right there. Okay, let's just rewrite it instead, because I forgot that, yeah, you're supposed to use like something where you lock the values in. So that's all fine. So F2, no, F4 multiplied by E4. All right, there we go. So we have that. This is going to be our parameters. I don't know if this lets me if whiteboarding if whiteboard's going to understand that I just want to paste this. But I can't see it, so okay, that's good enough. I mean, we don't have to get it perfect center. So yeah, this is the information that I got from Excel. Which, I mean, StatCrunch does do this for you, but it does it like in a much faster method because it's all in one, and you know, it's what MyMathLab uses. But in any case, like this is the same exact thing, and it kind of demonstrates, yeah, how did we find these different parameters? So finally, we'll just say that for a 95% confidence interval for the average rate of students, if we round to one decimal place, that's this is where we would lie between. We would have that the average is somewhere between 74.1 and 80.7, and we're kind of like 90%, or we are 90% confident in that measurement. So that's going to be it for this chapter. Now, what you can do is you can actually look at, different examples where you use the sample size, but remember that the sample size, it's basically using the normal value, like the critical z, multiplied by the standard deviation, so that'll be s, but then it's all divided by the margin of error, and this is all squared. So it's actually a good idea to go about looking at these other types of problems, like looking for like the sample size. But keep in mind that when you're looking at the sample size, the idea is that you're trying to find the largest. So in that case, whenever you're looking for the largest, then you'll use that you're going to have to round up instead of down. Okay, so be sure that you kind of look at those examples, and that's going to be it. And try to use, the calculator if you want to find these computations, because notice that I found basically all of this just by entering the given information into the calculator. And the calculator does have the capacity to look for the data. So like if you were to input the data into the calculator, it is as easy as, for example, entering it as a data set. That way you actually bypass the whole part about, like what is the mean, what is the standard deviation, and then see like here, you're just inputting it, and then that's mostly it with regards to, efficient methods of calculating the confidence interval.